let me record this class. Okay, let's see. Okay, B. She has a question. Hey, Professor, I have a question about homework, which is section 2.4171. Okay, I will go there. Right, if anyone has any questions, type your question in the chat. But now let's go to I get a wrong answer. Can you do it, please? 2.4171. Okay. Professor, if it's okay if I submit the homework late. Yes, it'll be okay if you submit late. All right. It disappeared from my open math at 10 a.m. so I couldn't see what questions and chapters to do. Oh, really? You mean the homework numbers disappeared? Ron, what do you mean by something disappeared? So let Yeah, they're on Blackboard. I posted on Blackboard, and oh, I see. So on my open math, once it's due, so it disappears. Oh, okay, that's good suggestion. So Rajab said it's posted in Blackboard, right? I posted both places. My collaborator is blank right now. Did professor start the class already? Yes, Kelly. Can you see my screen? I didn't know it was on Blackboard. Oh, okay. All right. Oh, okay. Just rejoin then. Let's see. Okay. Well, they are enjoying. Okay. Let's see what else. Okay. Let's go to 2.4171 for now. 2.4171. Oh, maybe you're not able. 171. Maybe you're not able to anti-differentiate, I guess. 171. Okay, for the following exercise, find the length of function of x over the given interval. If you cannot evaluate the interval exactly, use technology to approximate it. So this one, we want to evaluate from 0, 0 to 1, 1. Well, this should not be difficult, right, Bishan? So we know the formula to use, right? For finding arc length. To try to remember, it's anti-differentiate right here. So from C to D, where do we find C to D? Because we're given 2 points. So we're finding the x value. The smaller x value will be the lower limit. The greater x value will be the upper limit. Has nothing to do with the y, because we're going to anti-differentiate in terms of x. So if we do in terms of y, if we're cutting into infinite many pieces along x-axis, so this lower limit, upper limit will be x value. If we are cutting along y-axis, right, the lower limit and the upper limit will be y value. So just square root of 1 plus the function derivative squared. Let me see your comments. Let's see. Oh, okay. So the inside, so right, I know what's your question now. Did we talk about use trig substitution? Maybe we haven't learned that yet. That's why the question said, okay, let's go back to the question. Okay, I think you did it right. You did it right. Just the last one. Just read this. Okay. If you cannot evaluate the integral exactly, use technology to approximate it. So what is derivative of y? That's a 3 over 2 square root of x, right? Well, let's do that. Let's do it to the board. So x raised by 3 halves from 0 to 0, 1, 1. Let's go to whiteboard. So we have y equals, so our function is x raised by 3/2, right? So of course we take derivative. What's the derivative of that? This is 3/2 x raised by half, right? Then so we're going to cut along x-axis, right? So this one, it is a function in terms of x. So y is a function in terms of x. So we're going to cut along x-axis. We're given 2 points, 0, 0, 2, 1, 1. Because we're cutting along x-axis, so I'm going to take x value. So lower limit is 0. Oops. Lower limit is 0. Upper limit is 1. What's the integrand? The integrand is square root of 1 plus y prime squared. Well, what's y prime squared? 9/4x, right? 9/4x, right? Because we square this. Because we square this. Okay, 9/4x. Okay, use u substitution. So let u be, let u equals to 1 plus 9/4x. What's du? du equals to 9/4 dx, right? So we can write dx as dx equals to, because we're going to substitute dx equals to du equals to 4/9 du. Now we just substitute. So we substitute. Well, what's the u of 0? Let's also change our limits. So what's the u of 0? U of 0 equals to 1, right? What's the u of 1? Oops. U of 1 equals 1 plus 9/4. Right. 13, right? 13/4, right? 13/4. That's it. So let's change our limits. So lower limit is 1. Upper limit is 13/4. Okay. And then what's the integrand? Integrand is u, square root of u. Well, square root of u, we just write down as u raised by half. Then dx, we're going to change it to be 4/9 du. But 4/9, we can write outside the integration, right? So u raised by half, we know how to do that, right? Bixin, you can do the rest, can you? Do you want me to finish? Okay. So that's it, right? Okay, you get it now. Okay, great. All right, anyone has any other questions? Oh, you're welcome. Anyone has any other questions? Because last class we did 3 sections. 81 from 2.2. 81 from 2.2. Well, let's see this one. So what do we need to do? We need to draw the region bounded by the curves. Then use the disk method to find the volume when the region is rotated about x-axis. 81, right? Just draw the picture of those two. So this region is bounded by 4 things, right? This region is in between of 2. Well, let's draw that. X squared, because I think this 81 is all about drawing. It's not about how to solve this. To solve, it should be easy. But drawing itself, to be able to see where is the region, right? Where do we find our R, the radius? It may be a problem. So let's try to remember that x squared minus y squared equals 9. I think that's a paraboloid. I forgot the name. Paraboloid. So then x plus y equals 9, y equals 0, x. Let me take a picture of it because I may forget. So let's write down the question first. So we have an x squared minus y squared minus y squared equals to 9. Basically equals to 3 squared, right? Equals to 9. Well, x plus y equals to 9. But y equals 0, x equals 0. That's it, right? Y equals 0, x equals 0, x plus y equals 9. Yes. Tried using the disk method, but kept getting a really big number as answer. Okay, let's see what's going on. Let's try to draw the picture first. Oops. X squared, y squared, minus 9. I think that's called a paraboloid. Anyone remember that? X squared minus y squared equals to 9 graph. I'm checking. I want to see the graph. X squared minus y squared. It's like a paraboloid. Y squared minus 9. Okay, see here. X squared minus y squared. Okay. X squared minus y squared. We can draw a couple of points, right? If x, think about if x equals 0, well, we could think x squared equals 9 plus y squared. If y is 0, we get x equals plus minus 9, minus 3. Right. Y is 0, we get plus minus 3. But also our graph, let's see, this is a 3. Also, our region is bounded by x plus y equals 9. So if x equals 0, y will be 9. Oh, my 3 is 2. Oh, let's see this. Let's see. This is 3 for y-axis. This is 6. This is 9. So this is 9. So let's have this point. Then the other one, let's see, is 3, 6, 9. So I have 9 here. Okay, if x is 0, y is 9. If y is 0, x is 9. Right? Yes, I get this. I get this line. Right, so this is x plus y equals 9. So this one is easy. So I want to draw the x squared minus y squared equals 9 the last. Then y equals 0, x equals 0, right? X 0 is y-axis, and y equals 0 is x-axis. So now we see this triangle. Then let's draw x squared minus y squared equals 9. So if y equals 0, so we're in the first quadrant. So we only consider in the first quadrant. So we won't go to the other side of negative x value. So we have x equals to 3. Right? So we have x equals 3. So we have this point. Oops. We have this point. Then if y equals to 1, so I get, let's see, if x equals 0, oh, x won't be 0, right? Because if x is 0, y squared equals -9. So x won't be 0, so it never touches the y-axis. So how should I draw this? I think it's like a paraboloid, right? Oh, hyperbola? Is that hyperbola? Hyperbola. So how should I draw this? So if it's 9, that means x, let me search again. I don't know how to draw this anymore. Let me see this one. So 3, y equals to x. Yeah, this one is all about drawing because I haven't drawn anything about this. But let me just share with you about let me share with you so we can go together on Google search. Okay, so this is what I'm doing, or I can go to decimals. Let's try to go to decimals to try to graph it. So x squared, let me see if it graphs for you. X squared minus y squared equals to 9. Okay, great. Let's find a couple points. So because I have 9 and I have 0, 9, 9, 0. So this one goes through, so that's 3, right? 3, 0. Okay, great. Then this, where do they intersect? All right. Okay, now I know how to draw it. Let's go to the whiteboard. Let's go to the whiteboard. So our graph goes this way. So where do they intersect exactly? We will find out. Okay, so those two functions intersect at a point, right? At this point. Let me just mark red color. At some point here, right? Let's find out this point, because this point is important for us. Let's find out this point. So we set two functions equal to each other. So what do? We do x squared minus 9 squared minus 9. Oh, that's also going to be difficult to, oh, we just do this. Because both equals to 9, let's see, equals to x plus x, x plus y. Okay. That's y squared. That's y squared. So now this one can be factored as x minus y times x plus y. Then that equals to x plus y. Okay. Now we know x and y cannot be 0 at the same time. And xy can it be additive inverse, which means because I want to divide it by x plus y. So let's see if, let's if x plus y not 0, so we can divide, then x minus y equals to 1, right? X minus y equals 1. So we have this relation, x minus y equals 1. But I want to find out where do they intersect. I want to find out this point. So what else I could use? So first I set them to equal to each other, and if x plus y not 0, because we're working in the first quadrant, x plus y will never be 0, so that's okay. So I can divide by x plus y, I get x minus y equals 1. But that's a line width. So I need to find out how to use substitution. Oh, I see. I got you. So you want to, right, solve a y from the second one, substitute into the first one. Okay, that's a great idea. Yes, I wasn't thinking about that. So, okay. So Damon's suggestion is, why don't we get y value from the first one? We get a 9 minus x, right? Then we substitute into x squared minus y squared. Now y squared is 9 minus x, 9 minus x squared. Thank you. So x squared minus 9 minus x squared equals to 9. Then we solve from here, right? Then we solve from here. We just have to, so we'll get x squared minus parentheses. Well, this is a minus b squared form, perfect square. So we get 81 minus 18x plus x squared. So that equals 9. X squared minus x squared is gone. So we get negative 81 we just set the equation equal to y. We could do that too, because we're working in the first quadrant. Yes, then there are different ways of doing this. You see, you guys are smarter than me. Negative 81 plus 18x equals to 9, right? Let's see if I did it right. X squared minus x squared is gone. Negative 81 plus 18x equals 9. Okay, so we just solve. So we got 18x equals to 9 plus 81, 90. So x equals to 5. Yes, right? So x equals 5. If x equals 5, y equals to 4, because x plus y, oops, because x plus y equals to 4. Okay, so we get this point. So where do those two intersect is, thank you, 5, 4. Right, so that's this point. Now, let's think about this. Think about it if we try, let's think about finding area of this. Do we see we have to separate it in two parts, right? So we won't be able to find, so we need to split from here, right? We need to split from here. Then finding the area on the left-hand side of this bar and on the right-hand side of this bar. So that's when we find the area. So for the volume, we have to do the same thing. We have to do the same thing. So we need to find, we can use a disk method for both. We want to find the volume of when we rotate this triangle, right? When we rotate this triangle, this region. And then we want to find the volume when we rotate this piece with this curve. So we have to do 2. Then we add up those 2 volumes. Does that make sense to who asked this question? Who asked this question? I was trying to find out who asked. Still don't get it? Hold on a second. Which part you don't get it? Do you see so far does it make any sense to you? Why we try to find this point 5, 4, and why we split into 2 regions? Yes, right? Because let's see, if I ask you to find the area of this region, you have to split into 2, right? So it'll be the same thing when we try to find the volume. When we rotate this region about the x-axis, we won't be able to find the volume by doing, one calculation. We have to do 2 calculations. We have to think, let me see if I can highlight this. You see this triangle? Oops. We think about rotate this triangle from this one, from this. So this triangle. Rotating this area about x-axis. Then we get this, but a 3D object, right? I think this is round. What do we get? We get a cone, right? Are we using the disk method for the interval first? Hold on a sec. Are we using disk method for the interval 0 to 9 first? No. Okay, try to follow me. Don't even think about 0 to 9. All right, try to follow me now. Okay, so far we know this point is 3, right? And then this point is 9. So those two x values, you see those two x values, right? 3 and 9. Does it make sense? 3 to 9. Okay, all right, so now, and then you see the triangle, right? You see the piece. You see, let me use green color. You see this one, and then you see this smooth one, and then you see this piece of region, right? The green color. But the green color, we won't be able to find its area with one formula. So we need to cut into two. We need, let me change another color. Let me change this one. We need to cut from the x value equals 5. We need to split this region into two pieces. So one piece on the left is this piece. One piece on the right is a rectangle, is a triangle. Does that make sense? Okay. So now think about rotating this triangle first. When we rotate the triangle about x-axis, do you see we get a cone, a regular cone, like an ice cream cone? Do you see that? Do you have a piece of paper on your desk? Make a triangle, right? Just rotate about your finger. Rotate the piece about your finger. You will see a perfect cone. We don't even have to, we don't, right, but we will use the method of disk method to find the volume of this. So this is the first volume. Then the second piece, we just rotate this one. So for this one, because we're rotating this one, we're going to use the formula, disk formula, right? But the integrand is just this line. It's just x plus y equals 9, or y equals to 9 minus x. How do we know which area to choose? Could we have used 0,3? Okay, that's a great question. All right, so the question is saying the region is bounded by 4 things. You see these 4 pieces? Right? So first is bounded by this one. So this one we know is this one. Right? Is this, what do you call it, hyperbola? And then x plus y equals 9. X plus y equals 9 is this straight blue line, right? And then by y equals to 0, what's y equals 0? X-axis. What's x equals 0? X equals 0 is y equals to, x equals 0 is y equals to, I mean, x equals 0 is y-axis. It's bounded by those 4. Oh, hold on 1 second. I think I did the wrong area, did I? Good job. Thank you. Actually, I was doing wrong. Because this is bounded by x-axis and a y-axis. So it's this region. Thank you. I was doing wrong. Actually, this region, yeah, this region is still, let me see. Yeah, this is a hard question. So this region, let's see. So we have this point, we have this. We have this. All right, so that one means we have to subtract. Okay, let me redraw everything. So let's redraw everything. Clear. You are right. Thank you. So my region was wrong. I think my region was wrong. let's see, this is 9, this is 9. And then you find 3.3. So one third of that, let's see, that's here. So 3, 4, 5, 5 might be here. So my hyperbola goes this way. Yes, because it's bounded by y equals 0, which is the x-axis, and x equals 0, which is the y-axis, bounded by x plus y equals 9, this one, and x squared minus y squared is this one. So this is the region. All right, so even this region, we have to split into two pieces as well. So first, I'm going to change my color. First, we can find the volume. So when we rotate, actually, let's draw the other half, right? Something like this. When we rotate, we get this. We get something like this, right? We get something like this. So what's our radius? So disk method is just pi r squared. So when we try to find our r, we see this one and this one is not on the same. So let me mark those 2 points. So this point here, we found already 5, 4. And this point here, the x-intercept is 3, 0, 3, 0. So what do? We have to find true volumes, right? We have to find the volumes under this x plus y equals 9. When we rotate that, we will get, I forgot the name. So we'll find the volume when we rotate this piece, this piece. But then we have to subtract the volume of this piece, because this one, I don't know if you can see it. Oh, okay, I can use this one. You see here? Yeah. We have to subtract the volume of this, because this is like from 5 and here in the middle down to 3. So this part of the volume won't be there. So this volume we'll find according to this region, right? This region. So we use a big volume, which is, let me choose which color. Let's see, blue color. So we need to find a volume of this, right? And then subtract the volume of this. How do I draw that? Volume of this. This part, can you see it? Does that make sense? Which the R is not difficult, right? But from this one, let's set up the integral. Let's set up the integral, right? This one is a little bit troublesome, but as long as you have the right picture, it shouldn't be a problem. So we're going to do the outside. Well, what is the outside? The outside is going from 0 to, not to 3, right? 0 to 5. So 0 to 5. Why? Because this side ends at 5, right? Then let's put a pi outside the integration, then r squared. What is our r squared? It's y equals 9 minus x, right? I mean, the r is 9 minus x. If it doesn't make sense, then let me know. Okay, stop me. So the r of r is just this y value, right? Which is 9 minus x squared. 9 minus, okay, good. So the r of the big one It's 9 minus x squared. So we have pi r squared. So finding the volume of this, and it's going from 0 to 5, and the pi r squared, what's r? R is this y equals 9 minus x from x plus y equals 9. So subtract, this one is outside, minus this one, the red color. So how do we find the volume of that? That's going from 3 to 5, right? So lower limit is 3, upper limit is 5. What's a pi, right? Pi outside. What's r squared? What is our r? Can you tell me what's the radius of this? Do you see that's a parabola? X squared minus y squared equals to 9. So how do we find a y? So get a y squared equals to x squared minus 9, right? Then y equals to square root of, because we're working in the first quadrant, right? We don't need to take a negative value. So this is square root of x squared minus 9. Okay, so we just get this. So inside this, there's a y. Oh, we don't need to do that because we don't need to do this because we want r squared. We want y squared, right? So y squared is our r squared. It's just x squared minus 9. So x squared. So here is x squared minus 9 dx. Okay, let's see if this makes sense. So the volume from 0 to 5 for this one, 0 to 5, the volume of this object, of course the intersection is perfect circle, right? Subtract the volume of this piece is from 3 to 5. I'm talking about x value. So we're cutting along x-axis from 3 to 5, and the radius is just this y value, but this y value is the hyperbola, come from x squared minus y squared equals 9. That's because the square root and square cancel out. Yes, exactly. Because this y squared is just our r squared. Because y is our r. Because the area is pi r squared. Pi r squared. So this y squared is just our r squared. So the x squared minus 9. Okay, the rest is just calculation. So feels better than it? Okay, great. All right, great. You're welcome. You're welcome. And it's a good review. So anybody has any questions? Will we have to draw graphs or functions on exams? Yeah, sometimes you better. Because let's see this question, right? If you don't draw this picture, how would you know? You know, how would you go about set up the integrations? Right? You better draw a picture, just like this one. Without this picture, there's no way to do this question. Okay, so let me take a picture. So anybody has any other questions? How do we feel about the integration by parts? It's super important, integration by parts. Okay, no questions, let's go to, so today we're going to talk about trig integrations. So basically another kinds of methods. So integration by parts just come from product rule. Okay, whenever you get confused, it's just review product rule. Then you anti-differentiate product rule. So you get an integration by parts. Okay, trigonometry integrals. So we're dealing with sine and cosine in the integrand. . let's say this one. So we want to integrate cosine raised by j x sine x. So one example is cosine cube x sine x. So this is use u substitution, right? We let u be cosine x. Then du will be negative sine x dx. Right? Then we just substitute cos cube to be u cube. So let u be cosine x, du then equal to negative sine x dx. So sine x dx equals to negative du. So cos cube becomes u cube, right? And sine x dx becomes a negative du. And by power rule, so we get this. Then because this is indefinite, we just substitute back u into cos. So get negative quarter cos raised by 4 plus certain constant. Right, use substitution. So once the integral, we have both cosine and sine, that's easy to deal with. Sometimes difficult is we only have cos or we only have sine. So we have to, do something to make sine for cosine or cosine for sine. So in this case, the integrand is a product of two functions. We have both sine and cosine. Especially sine, you see sine doesn't have the power of sine is just 1, so which is perfect. So this kind is easy to deal with. Okay, so anytime you have any questions, stop me, all right? So let's see this one. This one, you know what? I'll let you try it. Try 3.5. Everybody, try 3.5. So those ones are easy ones. So we're going to talk about what about cos and sine. We do have integrand cosine and sine, but both be raised by a power more than 1. That's going to be a problem. Use u to substitute sine x. Yes, 1/5 of sine raised by 5 of x plus c. That's it. Because if we use u substitute sine x, du will be cosine x dx. Yeah, plus a number. Good job. Anyone has any questions? Yes, great. Okay. All right. Okay, good. So now, this one would be good if we have sine, cosine, both in the integrand, and the one of it, the exponent is 1, so that's the easy integration. But what if we have both raised by a certain power? Let's see this one. Example 3.9. So cosine raised by 2 squared, so cosine is being squared, and sine is being cubed. Now we have to do something. So we want to change one to be the other. Well, let's see. For this one, we're going to use the identity, trig identity, sine square plus cosine square of the same angle equals 1, right? This comes from trigonometry, Pythagorean theorem. So this is basically a trig Pythagorean theorem. So we want to rewrite sine cube x as sine square x sine x. Okay, good. All same. All right, great. So make the substitution sine square x equals 1 minus cos square x. All right. So then this integrand becomes cos square times 1 minus cos square, because 1 minus cos square is a sine square. Then you see we managed sine x dx, right? Oops. So now we managed sine x dx. So doesn't matter we use u for cosine or u for sine. If we use u for cosine, we would need du to be sine x involved, sine x dx, right? Of course, with a negative signs. If we want to use u substitute sine, and we want the integrand to have cosine x dx. So that's the key. That's the key. So now we managed to have sine x dx here. Oh, I cannot highlight it. So then we observe, we have cos square, we have 1 minus cos square, so no more sine square or sine in here. So we just use u substitute cos square, cos, right? So u substitute cos, then du equals negative sine x dx. That's exactly why we need to manufacture this sine x dx. So that becomes the integrand becomes u squared times 1 minus u squared, and sine x dx becomes negative du. So everything is being substituted in terms of u. The rest is just use power rule to anti-differentiate, right? When we finish, we change u back to be cosine x. So that's the trick. So sometimes one way doesn't work, you need to try another way, right? So the trick is we want to manufacture either sine x dx or cosine x dx. If we manufacture sine x dx, and the rest of the integrand needs to be cosine x. If we're able to manufacture cosine x dx, the rest of the integrand should be sine x in terms of sine x. Right? So that's the key. That's the goal. So this example again, you may try to do the other way. It'll be the same, right? So what do you try? You try to do cosine x dx. Then you have cos square. Cos square you can write as 1 minus sine square, right? So in that case, we would have 1 minus cos square times sine cube x cos x dx. Then you could use u substitute sine x. Then your du would be cos x dx, right? You could try the other way. So this one works for both ways. Sometimes one way is easier than the other way. Because sine x and cosine x are basically the same, right? Just when you see the graph is just being shifted pi over 2 units. And then if you shift the one graph pi over 2 units, it just overlap with the other. So which means sine x and cosine x, you know, are just closely related. It's just one function is a horizontal shifting of the other. So basically they come from the same root. Okay, anyone has any questions? All right, you try this one. Okay, you try 3.6. This one, I think probably only one way works. The other way wouldn't work. Right? If you try to split into sine x dx, that wouldn't work. You have to rewrite cosine cube x into cosine square x and cosine x. Then your du will be cos x dx. Then your u will be sine x. Okay, let's see. Alejandro, Li Zhen, Alexander, and Fu Jun, Nuzat, Nuzhat. Yeah, I would like all of you show your work, show your answer. Woodley, Zachariah. Okay, so let's see. So we split cosine cube x into cosine x, cosine square x. But cosine x dx will be our du, and we let u be sine x. Then cos square we can write as 1 minus sine square. 1 minus sine square. You guys, no, I see. Okay, that's the first answer, right? So now I'll do this one, do 3.6, then type your answer. Alejandra, Alexander, let me see who else. Okay, let's see. 1/3 of sine cube x plus 1/5 sine raised by 5x plus a number. Negative. Let's see, do we get negative? Wait, we should be 1 minus. We should have minus in it, right? It's plus. Right, we should have minus in it because we will get 1 minus sine square. So we should get sine square minus sine to the fourth power. So I would agree with 1/3 of sine cube x minus 1/5 sine raised by 5. Let's see. Oh, Alejandra, you're still working with the first one. The first one, right? You get the first one answer right, but we're working on this one, 3.6. It's sine cubic. No, okay, I agree with Darren's answer, sine cube x. So 1/3 of sine cube minus 1/5 of sine raised by 5. And also Woodley, yes. Yes, Shahaya, yes. Raw, yes. Yeah, Damon had a plus, minus, right? Minus, because we got a 1 minus sine square. Cosine square is 1 minus sine square. Can we do a real quick proof? Sure, let's do that. So that's cos cube sine square. So we get a cos cube. Zachariah, right, that's your integrand. That's still you in the integrand. You need to anti-differentiate. Sine square x dx. Okay. So now we should think with our mind, okay, for this one, we observe, right? If we split sine x out, if we split sine square x to be sine x, it'll be difficult, right? Maybe we're able to do it, but it will be difficult. So the easy way is to think, I'm going to split cosine cube. I'm going to split cosine cube. I'm not going to write x anymore, all right? Going to be cos square and cos. Why? Because I'm going to work cos with dx. So this is so I'm going to have cos x dx. That will be my du. So I'm going to substitute this with du. Right? So that's something in my head. Then what's cos square? So the rest of it, I need to write in terms of sine. So even I have a cos square there, I still have this guy there. And this guy now cos is with the dx now. I still have cos square. But I want u to be sine. So I want to rewrite this cos square as 1 minus sine square. Trig identity, right? Sine square plus cosine square of the same angle equals to 1. So cos square I'm going to write as 1 minus sine square. So I still have this sine square. So sine square. Right. Now when I multiply, I get a sine square, right? Sine square times sine square, negative sine square, I get a negative sine raised by 4. That's what Zachariah, that's what you got so far, right? That's your integrand. That's your integrand. Then we substitute. So we want u to be sine x. Then du, you see, is cosine dx, right? Cosine x dx. Right? So we can change this to be du, and this one to be u squared minus u raised by 4. Then du. Right? So we'll anti-differentiate by power rule. We have 1/3 of u cubed minus 1/5 of u raised by 5. Right? Then we substitute u back. Substitute sine x back for u. So we have 1/3 of sine cube minus 1/5 of sine to the 5th power plus a constant. Is this okay for? Does anybody has any question for this? Okay, all right. Okay, Zachariah, see that one. If we split as you did, right? So you split cosine x into cos x, cos square x. Oh, sine x. So you're missing something. You're missing sine square x, right? The sine missing square. You see that? Yeah. Yeah. Okay. All right, great. Let's keep going. Let's keep going. Okay, we have to review this. So we have a half angle formula, right? Or sometimes called double angle formula. It depends on how you write them. You know, half angle formula, double angle formula, basically the same formula. So it depends on, you talk from which angle of it. So cosine 2x equals to cosine square x minus sine square x, or equals to 1 minus 2 sine square x, or equal to 2 cosine square x minus 1. Right, so those ones you have to remember. Cos 2x equals cos square x minus sine square x. With this identity, cos square plus sine square equals 1. Cos 2x can be written in 3 ways. All right. And also this one, this sine square x equals to half of 1 minus cos 2x. Cos square x can be written as half of 1 plus cos 2x. Okay, so those are trig identities. So we need to use these trig identities for the integration. Let's see this one. This one, we have sine square x. So we may try the previous method, right? We're thinking, okay, I'm going to split sine square x as sine x times sine x dx. Then sine x dx, I can treat as du. If du is sine x dx, u would be negative cosine x, right? But we don't have cosine x. We have another sine x. So it's like we're doomed. We cannot go any further. So what do? We have to use this double angle formula. We have to use this formula. So we're going to write sine x square x as half of 1 minus. This half we can always put in front of the integration sign. So half of 1 minus cos to x. Right? So we're going to rewrite as that half of 1 minus cos to x, or half minus half cos to x. Right? Then half is easy, just half x, and the negative half cos to x, and I differentiate that. That is a half of sine to x. The half times half becomes 1/4, so I have a half x minus quarter sine to x plus a constant number. Any questions? Okay, let's keep going. Well, this one will be similar, right? So let's just try it. But cos square x can be written as this, 1 plus. So sine square can be written as 1 minus. Cos square can be written as 1 plus. Because when we do sine square plus cos square, you see we still get 1. Right? So 1 is 1 minus, sine is 1 minus cos to x. Cos square is 1 plus cos to x. Okay, so try this one. Try cos square x. Yeah, half x plus quarter cos to x plus c. That's it. That's it. That's it. Anyone has any questions? We just use the formula. So about to change to be this formula. Change to be this one. So cos square we rewrite as a half plus half of cos to x. Okay. Then we anti-differentiate that. Right. We write as half, or anti-differentiate half. This is half x. Then we have cos to x, half of cos to x, or half of cos to x is just quarter of sine to x, plus a constant number. Yes, sine to x. What do you mean? Damon, what's your question? Or maybe I said something wrong. You see, Ali's answer is right. Shahara's answer is right. Oh, Shahara, you're missing x. Yes, you're right. Half x. Yes. Okay. All right. So let's keep moving. Okay, there are a couple of cases to consider, right? So let's think we have cosine raised by j, sine raised by k. So if k is odd, so if it's k under the exponent of sine, we will manufacture sine x from that. So we will write sine raised by k to be sine raised by k minus 1 and sine x. Okay. Because then k will become even. K becoming even, we can use the identity to rewrite sine raised by, k minus 1 will be even. If k is odd, k minus 1 will be even. Then we can use identity to rewrite the even sign. Or similarly, if the exponent of cosine is odd, we're going to rewrite the cosine. Right? Cosine raised by j to be cosine raised by j minus 1. Then cosine j minus 1 will be even. and the cosine x. Cosine x, we want the cosine x dx to be the du. All right. So looking for the odd exponent of sine or cosine to work with. If both j and k are even, we use this half angle, or some people call double angle formula. This is basically what we did earlier, right? Yes, but yes, basically earlier we did is we only have sine x dx or cosine x dx, but now we have both sine and cosine with a higher exponent. So we have to split one out to be sine x dx or cosine x dx. Yes, you're right, it's similar. We just have to do one step further. So if both j and k are even, we have to use this half angle formula. All right. So sine squared right as half minus half cosine 2x. Cos squared right as half plus half cos 2x. Okay, let's see this example. So this one we have cosine raised by a, sine raised by 5. So what do? We rewrite sine raised by 5 because 5 is odd, right? Because 5 is odd. Well, if both odd, that means we have a choice. We can choose either one to work with. But here sine is raised by odd exponent, so we're going to work with sine. We're going to write the sine raised by 5 to be sine raised by 4 times sine x dx. Then sine x dx will be our du. Then cos x will be our u, will be our negative u, right? So, right, first, so we split sine raised by 5 to be sine raised by 4 and sine x. Then we have sine square x raised by 2, that's sine raised by 4. So we rewrite, so sine square x, we want to write as 1 minus cos squared. We want to use the identity. Right? Once we use the identity, sine disappears. So it's substituted into cosine. So we have this u, and sine x dx is our negative du. Then the rest is just calculations, right? In the end, we got the negative 1 over 9, cos raised by 9, plus something. All right. So the key is to remember to work with the odd exponent. To work with the odd exponent. To split 1 from the odd exponent. So this is sine raised by 5. So split it into sine raised by 4, which is even, then sine x. All right, so you guys try, oh, this one. Well, this one we don't have a cosine, right? So what do? What do? We have to use sine squared x equals to 1/2 minus half cos 2x. So we write as sine squared, sine raised by 4, we write as sine squared squared. Sine squared is half minus half cos 2x squared. Then this is perfect square. We just expand. So get this. Then you see this cos square x, we have to apply one more time, right? So cos square 2x, we write as half minus cos square x, we write as half plus half cosine 2 times 2x, which is cosine 4x. That's here. So we get a quarter is a cos squared 2x, that's half plus half cos of 2 times 2x, which is 4x. So we applied twice of the half angle formula. Anyone has any questions? Okay. Keep going, the rest is just calculations. All right, so okay. Try this one, try 3.9. Here we have cosine squared 3x. So that means we want to rewrite this one as half plus half of cosine 2 times 3x, which is 6x. Okay, I'll give you a couple minutes to do this. Remember, cos square is half plus half of cos double the angle. Okay. So half x plus cosine plus 1 over 12 cos 6x plus a constant. Okay, Golem, why you have a minus? Remember, sine square is minus, cosine square is plus.
Yeah, I fixed it. If you look down.
Oh, okay, I see it. Yes. Okay. Okay, but your parenthesis is not in the right place. All right. So sine, you mean 6x. You probably could put the parenthesis around 6x. Okay, good, good, good. That's it. Anyone has any questions? Why is it the carrier? Why is it 6? Because when you apply double angle, that becomes 6x, right? Let me bring you. So this angle is 3x. This angle is 3x. So cosine? Remember cosine square x, the angle is x, equals to half plus half cosine 2x. But now it's 3x. So we have a double 3x. So the angle becomes 6x. Does that make sense? Why is it sine and not cosine though? Oh, hold on 1 second. It should be cosine. It's not sine. It should be cosine. Oh, I see. Okay. Okay, good catch. Good catch. So, okay, Shahaya, James, and Bixin, Opempo, Golem. Okay. You guys did sine x, sine 6x. No, it's not sine 6x, cosine 6x. So Ali did it right. Okay, so remember sine square equals to half minus half cosine 2x. And the cosine square x equals to half plus cosine 2x. Okay, some people call half angle, some people call double angle, depends on which one you talk about. Okay, thank you. It is cosine. Okay, cosine of 6x. All right, let's keep going. Okay, Damon. All right, let's go back to the formula. It all comes from this formula. Okay, so make sure you have this one, on your notebook. Sine squared x equals 1 minus equals half minus half cosine 2x. Now change this x to be 3x. Change the angle to be 3x. So if the angle is 3x, the formula becomes 1 minus cosine 6x divided by 2. Does that make sense? For cosine square x, you see that's 1 plus cosine 2x over 2. Basically, it's a half plus half cosine 2x. You see the original angle being doubled. Now think about cosine square 3x. So the angle is 3x now, right? If the 3x double 3x, that's cosine 6x. But the question is cosine square 3x. Yes, Bixin. So the angle is 3x instead of x. So the cosine 2x becomes 2 times 3x. That's why it's cosine 6x. Does that make sense? In example 3.10, it was changed to be 3.10. The sine 2x. Hold on a second. 310. This one, right? So this one is sine square x, right? So in the end, oh, okay. We have to anti-differentiate. Oh, maybe, right. So we were talking about different things. Let's see. Hold on 1 second. Yes. Because after anti-differentiation, the cosine becomes sine. That's right. I was wrong. Right. And all of you are right. And Ali and I was wrong. We're talking about, no, not this one. This one. Yes, it should be sine. So after anti-differentiation, after integration, so we have cosine 6x in the integrand. So after integration, it should be sine 6x. That's right. Sorry, guys. Right. I was making mistakes. You guys are right. What is the right answer? Okay, let's go from the beginning. Let's go to the whiteboard. Let's go to the whiteboard. Sorry for the confusion. So we have a cos square. The angle is 3x. The angle can be anything, right? dx. So we want to use the formula cos square x equals to 1 plus cos 2x. Okay, so this is the key. So the angle from x changed to be 2x. All right. So now our angle, just pay attention to the angle. Our angle is not x. Our angle is 3x. Right. So we just follow that. we change that to be 1 plus cosine double the original angle, double 3x, which is 6x. Right? Okay. Now anti-differentiate. Half becomes half x. Well, half cosine of 6x. Well, cosine 6x, anti-differentiate that. That's 1 over 6 sine x. So 1 over 6 times 1 over 2, that's 1 over 12. Sine 6x comes from, cosine 6x is the differentiation of sine of 6x. Right, just plus some constant. That's it. Does this make sense? Well, anyone has any question? Any questions? Okay, all right. So that's it. Okay, let's go back to all right. Let's go back. Let's see. So this is saying to integrate products involving sine AX, sine BX, cosine AX, cosine BX. We have this kind of substitution. Let's see, sine AX times sine BX. So I have sine. That's half of cosine A minus BX minus half of cosine A plus BX. If sine cosine, I have this. Wow. Okay. I don't remember this. If you think you can remember this, try to remember it. All right. Otherwise, so cos. So we have sine, cosine, and cosine. If you remember this, all this comes from, remember we have sine of A plus B, right? So AX plus BX. And we'll have cosine, we have formula of cosine of that. And all this come from there. So you could use that. Well, that's a lot to remember. So apply the identity sine 5x cosine 3x equals half of sine 2x plus half of cosine AX. If the exam has this, if I make the final exam, I will make the midterm. I think I will make it depends on me to make the midterm and the final. If I do make these kind of questions, I'm not going to require you to memorize this. All right, I will give you a cheat sheet. All right, because I can remember myself. Anything I cannot remember myself, I wouldn't ask you to remember it. But for homework, because you can, check this as reference. So let's just try this one. So this equals, so we have sine AX cosine BX, that equals to half of sine AX minus BX, which is 2x, and a half of cosine AX plus BX, which is AX. So we get this. Then when we integrate, well, after that, that's easy integration. Okay, let's skip this one. Okay, so secant square, integration of secant square equals to tangent x plus constant. And secant tangent equals to secant plus constant. Tangent equals to ln secant. absolute value of secant plus constant. And secant equals ln absolute value of secant plus tangent plus constant. Let's see this example. This example, we have secant raised by 5 and tangent x dx. So we're rewriting secant raised by 5 tangent x as secant raised by 4 secant x tangent x, because we know how to anti-differentiate secant and tangent. Secant tangent anti-differentiation just secant. So use u substitution, so u equals to secant, then secant tangent dx is just du. Then we substitute, so we get 1/5 secant raised by 5 plus c. All right, so you have to right use this 1, 2, 3, 4. There are a lot of formulas plus the 4 before. So when you do homework, so I will assign you homework to practice those formulas. And also, secant tangent we can always rewrite in terms of cosine and sine. So sometimes you don't want to deal with the secant, cosecant, tangent, or cotangent. Just change them to be sine and cosine. Just go from there. That's usually I do. Okay. But I will assign you some homework for this to practice on it. So I'm going to skip all this. All right. All right, so I'm going to assign you some homework from here. And then let's see, what's 3.3? Trig substitution. All right. Right, so let's go from this. This all from Pythagorean theorem, right? If you see square root of a squared minus x squared, square root of a squared plus x squared, square root of x squared minus a squared, right? You see the first one and the third one is the two legs, is the length of the two legs, right, of a right triangle. And the square root of a squared plus x squared, we can treat that as a hypotenuse of a right triangle with one side a with another side of x, right? So trig substitution is all about this. So let's see, integral involving a squared minus x squared. So this is one of the legs, right? So a squared would be the hypotenuse. So this is the length of one leg. Right? We have hypotenuse being a and x being the other leg. So let's see this one. So what do? We could do this. We could substitute x as 3 sine theta. So let me see if I can find a triangle. Oh, here. Good job. Okay, let's see here. All right. So I can treat square root of a squared minus x squared as one side, one leg of a right triangle. So the hypotenuse is a, because I have a squared minus x squared. The other leg is just x, right? So I'm treating this square root of a squared minus x squared is the length of the other leg. So I'm going to call the angle opposite to x theta. Because if a is hypotenuse, the opposite angle has to be right angle, right? So just call the theta to be the opposite angle to x. So what is the relation? We could see sine theta, right? Sine theta is x over 8. Right? Sine theta is x over 8. So just from this, we just get a right triangle. The hypotenuse is 3. One leg is x. So this is the length. Square root of 9 minus x squared is just the length of the other leg. So in this case, we can write this one. So how do we write this one? one we substitute x in terms of 3 sine theta, right? Because of this right triangle here. So theta, sine theta, we can write as x over a. So what's x? X equals to sine theta multiplied by a. Well, x equals a times sine theta. Okay, so from this picture. So we're going to substitute x into a times sine theta. Right. So we rewrite this square root of 9 minus x squared as square root of 9 minus 3 sine theta squared. 3 sine theta squared. Right. Then what about dx? Right? If x equals 3 sine theta, well, dx equals to 3 cosine theta d theta. Right? Just think x as a function in terms of theta. Right? So dx d theta equals 3 cosine theta. But for integration, we like to write dx equals 3 cosine theta d theta. We like to write d theta on the other side. So we substitute dx into 3 cosine theta d theta. So now we have this substitution. We have square root of 9 minus 3 sine theta squared times 3 cosine theta d theta. Right? So we can factor out 9 from under the square root sign. So that's 3. 3 times 3, we get this 9. Then inside becomes 1 minus sine squared. What was 1 minus sine squared? That's cos squared. So you just get a cosine squared. Well, cosine squared square root, that's just cosine. Cosine, oh, I think this is a typo. There's no more square here. No more square, just cosine theta. So when we anti-differentiate that, we just get 9 sine theta, right? Plus a constant. And then, that's it. And theta we can rewrite. We can rewrite theta as, go back to the triangle, because theta wasn't given in the very beginning. So what is theta? Theta is arcsine. We don't want to use arcsine. Well, I guess that's fine. We just leave the answer as theta. Theta, we just have to give this triangle, all right? We just have to write this triangle. See, our answer is just in terms of theta. A cosine theta should be A cosine theta. So this one is a typo O. Okay, this one is a typo O. There's no more square. Because we have square root, they cancel each other. Just cosine square theta, d theta. Well, let's see a good example. So the integral involves the square root of a squared minus x squared, 1 over square root of a squared minus x squared, or x over square root of a squared minus x squared, or x multiply square root of a squared minus x squared. So we all use, when we encounter integral involves this kind of situations, we use trig substitution. We will use x equals a sine theta and dx equals a cosine theta d theta, all from the picture. Then a cosine theta equals the square root of a squared minus x squared, right? As we just did before, we just showed before. So what's theta? Theta is, of course, arcsine of x over a. Well, let's see this example. All right, so from the beginning again. So we want to anti-differentiate square root of 9 minus x squared. Right, we draw this picture. Right, we draw this picture. We say, okay, 9, we treat it as hypotenuse square, which is 3. and x is the other leg. And then square root of 9 minus x squared is just this leg, right? Then from here, we're going to sine theta equals to x over 3, or x equals to 3 sine theta. Okay, so we substitute x into 3 sine theta, then dx equals 3 cosine theta d theta. We substitute in this. So in the end, we get, because it's under square root, so when we do cosine square root, we have to put absolute value, right, to see it has to be positive or non-negative. It has to be non-negative, because it could be 0, right? Then why is it square? Oh, okay, yes, we have cosine. We did get a cosine. Okay, that wasn't a typo. This wasn't a typo, because we have cosine. We have this cosine. We have this cosine. We have cosine square root. Then we have this cosine. So we did get a cosine square. Well, cosine square theta, we could use double angle formula. Cosine square of theta equals a half plus cosine 2 theta, right? Then we can anti-differentiate from there. Right, so cosine square equals a half plus half cosine 2 theta d theta. Then from there we'll get 9 over 2 theta plus 9 over 4 sine of 2 theta, because anti-differentiate half of cosine 2 theta, that's 1/4 of sine of 2 theta. Then multiply this 9 plus some constant. Right. And what's theta? We could just give a definition of theta, just arcsine of x over 3. Well, I think it's okay if we have the triangle, right? We marked where is theta. And we can leave the answer as this, 9 over 2 theta plus 9 over 4, 2 sine theta, cosine theta. Well, what is the 2 sine theta, cosine theta? That's just sine 2 theta plus c. I think this line is a perfect answer. If we have the, so this line, okay, this line is a perfect answer with the triangle. Okay, if you draw the triangle, then you mark the theta with this answer, you know, that should be fine. We don't need to do the rest. Okay, any questions? So for trig substitutions, it's all about draw a right triangle, okay? If we have a square root of something plus x squared, we know that's a hypotenuse, right? If we have a number minus x squared, we know that's another leg. So it's all from this triangle. All right. So I'm going to assign you some homework from 3.2, 3.1. I mean 3.3. Okay, anyone has any questions? Okay, it's time. I'll let you go. And so today's Thursday, right? So have a good night. Have a good weekend. I'll post the homework. Okay. Thank you.